Welcome back, ladies and gentlemen, to the free response question review. Today we will be looking at the 2016 Calculus BC number 5 question from the non-calculator. This question was also shared on the AB version of that year. It is a funnel that we're dealing with, and we're going to answer some questions about this cool funnel here. It says the inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by r equals that thing, where h is between 0 and 10, and the units of r and h are in inches. Let's go and find the average value of this funnel. Well, average value, when I hear the word average value, I think about 1 over b minus a. So 1 over b minus a would be 1 over 10 minus 0 times the integral from 0 to 10. Since I'm finding the average radius of the funnel, I will go and integrate r. Well, what is r? R is this function here, so it's going to be 1 over 20 and then 3 plus h squared dh. This 1 over 20, I'm going to kick him out and call him 1 over 200 from 0 to 10 of 3 plus h squared dh. Haven't done any calculus yet, but that's going to change right now. I'm going to start doing some calculus here. 1 over 200, that's going to be 3h plus h cubed over 3. And that's going to be evaluated from 0 to 10. And now from here, I'm going to go and evaluate him. So 1 over 200, and I will get 3 times 10 plus 10 cubed over 3 minus 0. Now, I like to put the minus 0 in there. It lets me tell the graders that I've acknowledged the existence of what happens when you plug 0 in. Obviously, it goes to 0, but I just want to make sure they know that I know. So at this point, you're actually done. You don't need to worry about simplifying, but just because if you're going to check the answer guide, it would be 30 plus 1 with 3 zeros over 3. And when all is said and done, the answer ends up becoming 109 over 60. After all the simplification is complete. Let's take a look at B. It says find the volume of the funnel. Well, this volume is going to be found by taking this funnel and rotating him this way. Rotating him. So with rotational volume, that's going to be pi r squared h. So how do we find out what that is? Well, it's going to be pi times the integral from 0 to 10. R is really the radius value at that moment in time. So that's going to be our 1 over 20 and then 3 plus h squared, all squared dh. So let's go and clean him up a little bit before I do some integration. I'm going to go and call him, I'm going to square the 1 over 20, giving me pi over 400 after I kick everything out. And that's going to get me 3 plus h squared squared dh. Please don't distribute the 2 into those. That would be unfortunate. We are not going to do that. We are not going to make that mistake. So then we get pi over 400 integral from 0 to 10 of, if I multiply him all out legitimately, I will get 9 plus 6h squared plus h to the 4th dh, which will then equal pi over 400, and then I'm going to integrate this expression here. So 9h plus, looks like, not 6, sorry, h cubed times 2 plus h to the 5th over 5. And that is then evaluated from 0 to 10. So what does that look like? It's going to be pi over 400, 9 times 10, plus 2 times 10 cubed, plus 10 to the 5th over 5, minus 0. So what does all of this become if I was to actually try and simplify this thing? Well, I get pi over 400. That'd be 90 plus, this would be 1,000, so 2,000. And this would be plus, well, 10 to the 5th is really 10 times 10 times 10 times 10 times 10 over 5. Well, that's going to be a 2 right there. So that's 10 to the 4th, so that's 10, 1 with 1, 2, 3, 4 zeros. So 20,000. So that's going to end up becoming 22,090 over 400 pi. And then a couple of the zeros can knock away, and you will end up getting 2209 pi over 40. And that is your answer for part B. If you wanted to simplify it, you could actually have been done right here and gotten full credit. All right, let me clean up the board real quick, and then we will move on to part C. All right, we've got a nice clean board that we're working at. For part C, it says the funnel contains liquid that is draining from the bottom at the instant when the height of the liquid is 3 inches. So when h equals 3, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. This sounds like a related rate problem. Since we're decreasing at 1/5 inch per second, our 1/5 will be negative. At this instant, what is the rate of change in the height of the liquid with respect to time? Okay, so what do they want from us? They want dH dt when these two statements are true. Well, in a related rate problem, they always give you a rate and then they want a rate back. And then once that's been established, then you have to establish the relationship. Remember, it's your responsibility to establish that relationship, except this time. Because in this case, they give you the relationship off the cuff. So from here, because we have all of this information, we have an R, we have an H, we have a bunch of numbers, we can do this. R is equal to 1 over 20, 3 plus H squared. Now it's up to you. I will probably just distribute just because I like to see things better that way. I'm not always consistent with when I distribute and when I don't distribute, but everyone will find their style. Well, from here, I'll get dr over dt equaling the 3 over 20 is going to go bye-bye, and I end up with 1/10 h. Please don't forget dH dt. This is a related rate problem. Well, what do we know? We know that dr dt is negative 1/5. We know that the 1/10 is going to be there, and we know that 3 is the height at the time in question. And dH dt is the thing we're going to solve for. So what I get is I get negative 1/5 equals 3/10 dH dt. I'm going to kick that dude over, so I get dH dt equaling 10/3 times negative 1/5. Those guys will cancel, giving me dH dt equaling negative 2/3. And I believe that is going to be what wraps up this video. It doesn't ask you to justify anything, but if it did, you could say that the height is, say, changing. If you wanted to keep the negative in there, the height is changing at a rate of negative 2/3 inches per second when h equals 3 inches. Okay, I think that's going to wrap it up for this FRQ. Go ahead and leave questions and comments in the comments area. Your input is always appreciated. And we will see you in the next one.